Welcome to Beyond the Lens, where history comes alive, and every documentary takes you deeper than ever before. History isn't just written in books. It's carved into ancient ruins, hidden beneath the oceans. For breathtaking this is a journey beyond the lens.
Imagine Paris in 1887. It is a city defined by stone, massive cathedrals, heavy masonry, and elegant, uniform boulevards. France was preparing for the 1889 Exposition Universelle, a World's Fair intended to mark the centennial of the French Revolution. The government required a centerpiece for the fair, a monument that would demonstrate French leadership in science, engineering, and industrial output. Out of more than 100 architectural proposals, the committee selected a radical design from the engineer Gustave Eiffel. His radical plan involved a 300-meter tower, at the time the tallest structure on Earth, constructed entirely out of iron. Critics argued the design was a physical impossibility. The engineering standards of the day struggled to account for how a structure that tall, built with such a lightweight frame, could survive high-altitude wind loads and its own weight. The local elite were appalled. Prominent artists and writers signed a manifesto against the project, describing the tower as a gigantic black smokestack that would ruin the character of the city. Beyond the cultural backlash, Eiffel faced a hard logistical wall. The entire tower had to be designed, manufactured, and assembled in exactly 2 years to meet the fair's opening date. Eiffel realized that traditional on-site construction methods, where parts are measured and cut as the building rises, would be too slow. He had to separate the act of making from the act of building. Construction began on January 28, 1887. Before the tower could rise, the crew had to solve a gravitational problem beneath the surface. The structure would eventually weigh 7,300 tons. Supporting that load required 4 massive, deep-set concrete foundations. For the 2 legs closest to the River Seine, workers encountered a major obstacle. The soil was saturated with water and prone to collapse. Eiffel deployed compressed air caissons, large metal chambers using pressurized air to keep the area dry. This pushed the water level down, allowing men to work below the water table. Inside these dry pockets, laborers poured massive concrete blocks to anchor the tower's legs. While the crews in Paris fought the mud to secure the site, the real momentum of the project was generated hundreds of kilometers away. Eiffel's factory in Levallois-Perret operated as a high-precision manufacturing plant, far removed from the dirt of the construction site. By utilizing concurrent workflows, the tower's components were being manufactured at the same time the foundations were being dug. The factory produced more than 18,000 individual iron components, each one identified by its own unique serial number. Precision was the priority. Every single rivet hole was pre-drilled in the factory with an accuracy of 1/10 of a millimeter. Each piece was designed to integrate perfectly with the next, moving the complex engineering decisions away from the job site and into the controlled environment of the factory. This shift meant the work in Paris was no longer a matter of traditional construction, it was a matter of rapid assembly. These 2 efforts converged just as the foundations were finished. The first prefabricated iron beams arrived on site, ready to be joined. Because components were manufactured with such high tolerance, they fit immediately. There was no need for on-site trimming or re-drilling of the iron. This speed is visible in the progress photos from 1888. The base and the first level were assembled with incredible efficiency. With the difficult engineering already solved in the factory, the structure rose at a rate that defied contemporary expectations. Eiffel met the 2-year deadline because he successfully moved the slowest parts of the project, the measuring and the cutting, off the field and onto the factory floor. The tower was completed in just 2 years and 2 months, standing as the tallest man-made structure in the world. Upon its opening, the sheer scale of the achievement silenced the petitions. The public was captivated by the height and the intricate iron lattice. The 1889 Exposition Universelle drew millions of visitors, and the tower served as physical proof that France mastered the materials of the industrial age. Gustave Eiffel's approach demonstrated that architectural scale could be achieved through the precision of mass production. By finishing a project of this magnitude on schedule and under budget, Eiffel proved that high-precision, off-site manufacturing was a viable way to build at a massive scale. Today, 7 million people visit Paris yearly to stand beneath the Eiffel Tower. It's fixed in our minds as a permanent fixture of the skyline. When it was first proposed in the late 19th century, the people of Paris hated it. Prominent artists and writers publicly campaigned against it, calling the iron lattice an ugly mistake. And their protests were largely ignored for one simple reason: the tower wasn't going to stay. Its initial construction permit allowed it to stand for exactly 20 years. After that, the city was legally obligated to tear it down and sell off the iron as scrap metal. Which raises an obvious question: why would anyone pour vast sums of money, risk human lives, and push the very limits of 19th century engineering for a structure destined for the junkyard? The answer to how this condemned monument survived lies in the math and the muscle required to actually build it. By mid-1887, the massive iron foundation was finally pushing up for the Parisian soil. Hundreds of skilled workers climbed higher each day to assemble the heavy base sections. Holding these massive beams together required more than 2.5 million individual rivets. Teams had to heat each one until it was red hot, insert it into the iron, and hammer it completely tight before the metal cooled. All of this was done hundreds of feet in the air, operating heavy steam-powered cranes while balancing on temporary wooden scaffolds. Yet serious accidents were rare. The chief architect, Gustave Eiffel, mandated strict safety rules. He required movable guardrails and safety belts, creating a standard of worker protection that was practically unheard of for the era. But protecting the workers and maneuvering heavy iron only got them so far. The true threat to the project was a geometric puzzle waiting for them 150 feet off the ground. This schematic shows the critical engineering bottleneck. The tower was built on 4 separate giant legs that curved inward as they rose. To carry the enormous weight of the upper structure, these 4 massive arcs had to meet perfectly at the first horizontal platform. A deviation of even a few millimeters would throw the entire alignment off. To prevent a collapse, engineers installed hydraulic jacks underneath the base of each leg. This allowed them to make microscopic height adjustments, raising and lowering thousands of tons of iron until all 4 sides clicked flawlessly into place. Following that precise alignment, it took a relentless 2 years, 2 months, and 5 days of manual labor to finish the framework. On March 31, 1889, the construction was officially complete. Gustave Eiffel scaled the summit and raised the French flag over a cheering crowd. At 300 meters, or nearly 1,000 feet, it became the tallest man-made structure on Earth. It would hold that global record for more than 4 decades, finally outpaced only by New York's Chrysler Building. Through strict safety rules and millimeter-perfect hydraulic engineering, Eiffel's team had successfully erected a record-breaking masterpiece, and the city of Paris was still legally bound to tear it down. As the years ticked by, that 20-year expiration date loomed closer. The scrap dealers were ready. But at the exact same time, scientists were experimenting with a brand new form of technology: wireless telegraphy and early radio communication. Broadcasting those invisible signals over long distances required height, and there was simply no better, taller, or more stable antenna available than a 300-meter iron spire sitting right in the middle of Europe. The French military quickly realized the tower's utility for intercepting enemy communications and broadcasting signals to troops on the front lines. By the time World War I broke out, its strategic value made dismantling it completely unthinkable. The Eiffel Tower survived the junkyard because its precise engineering made it strong enough to adapt to a technological future no one had predicted. What an entire city once dismissed as a temporary eyesore stands today as a permanent reminder that some of our greatest achievements begin as impossible ideas.